So for the longest time, we've thought of AI as this lightning-fast thing, right? Spitfire answers, instant results. But something huge is happening right now. The entire field is shifting gears. It's moving away from just pure speed towards something that looks, well, a lot more like deliberate human thought. Let's break down what that really means.
All right, quick question for you, and don't you dare reach for that calculator. What's 17 times 24? Just take a second. Feel what's happening in your brain. You probably have a gut guess, right? But to actually solve it, you have to kind of switch gears. You have to start calculating step by step. That little mental gear shift you just felt, that is the perfect way to understand everything that's happening in AI today.
And that little gear shift you just felt in your own head, well, that's what psychologists call the difference between System 1 thinking, that fast, automatic, gut reaction, and System 2 thinking, which is that slow, deliberate logic you have to consciously fire up. This idea, borrowed straight from how our own minds work, is absolutely crucial for understanding the next generation of AI.
So how does this connect to AI? Well, the AI we use every day, your ChatGPTs, your Claudes, they're absolute wizards at System 1 thinking. You could honestly just call them intuition machines. Now, the fancy technical term for how they work is autoregressive. It sounds super complicated, but all it really means is that they are incredibly sophisticated pattern matchers. Their one and only job is to predict the next most likely word based on the mountains of text they've already seen. So their whole process is basically a straight shot, just like this. You give it a question, Q, and it makes this lightning-fast, intuitive leap right to the answer, A. No steps in between. It's pure pattern recognition, all gut feeling. But, and this is a huge but, that speed is also its biggest Achilles heel. So, what happens when a problem is just too tricky, too complex for pattern matching to solve it? Well, this is where today's AI smacks right into a brick wall, a fundamental limit to its purely intuitive approach. Look, here's the thing you have to understand. These models are world champion mimics. They are phenomenal at recognizing patterns they've seen before. But if you give them a problem that's genuinely new, something that requires actual logical steps, they can completely fall apart. And this chart right here, it just lays the problem bare. Researchers gave these models math problems that looked a lot like their training data, and they absolutely nailed it, almost perfect. But the second the problems got just a tiny bit more complex, boom, performance just falls off a cliff. And here's the kicker. It's a phenomenon called shortcut learning. Instead of actually learning the rules of math, the AI is just learning to recognize the shape of the problem. It's turning a complex reasoning task into a simple pattern-matching game. And that strategy, as you can see, is incredibly fragile. So to get past that wall, to break through that reasoning ceiling, researchers are now laser-focused on one thing: building AI's slow brain. They are literally teaching it how to do that System 2 style of thinking by, well, getting it to show its work. And the number one technique they're using to do this is called chain of thought. And honestly, it's pretty much exactly what it sounds like. Instead of letting the AI jump straight to the answer, you train it to first generate all of the steps it took to get there. And you can see the difference clear as day right here. We're moving away from that simple, direct Q to A jump to this new, deliberate path. Now, it goes from the question through a whole series of reasoning steps, and only then does it get to the final answer. It's a totally different way of thinking. This quote from a UCL researcher, Jun Wong, just hits the nail on the head. The goal isn't just about getting the next word right anymore. The new goal is about rewarding a good process. It is a fundamental shift in what we're even asking these AIs to do. Okay, so what does this new Thinker's Toolkit actually have inside it? What are the components that make up this new cognitive architecture? First up, you've got something called RAG. And the best way to think about it is like giving the AI an open book test. Before it even tries to answer you, it goes and does a quick search in an up-to-date knowledge base. This is what grounds its answers in reality and stops it from just making stuff up. Next, we have process reward models, and this is where it gets really clever. Instead of only giving the AI a reward for getting the final answer right, you give it a little reward for every correct step it takes along the way. You see, it's all about teaching the AI how to think, not just what to think. And this all comes together in something called the agentic loop. It's a cycle. Step 1, act. The AI does something, like a search. Step 2, observe. It looks at the results. And then step 3, reflect. It asks itself, is something missing here?
before planning a better, smarter action for the next loop. It's this constant cycle that really mimics how a human researcher works. All right, so we've built this new thinking machine. What does that actually mean? What can it do? Well, the results are, frankly, mind-blowing. But all this new power, it comes with a whole new set of massive, maybe even show-stopping challenges.
I mean, just look at these gains. We're talking about hitting the 89th percentile in competitive programming. That's insane. Or placing in the top 500 of a US Math Olympiad qualifier. And on hard science questions, these new models are already outperforming most human PhDs. But, and you knew there was a but coming, these breakthroughs are creating some enormous hurdles. The kind of problems that in the past have triggered these long, cold AI winters, where funding and progress just grind to a halt.
First up, let's talk about money. Cold, hard cash. This kind of deep, multi-step thinking is not cheap. A single complex query, we're talking it could cost $5, maybe even $10 every single time. That's just not going to work for everyday use, right?
And then there's the energy problem. And look, this isn't a software thing you can just optimize away. It's physics. Training and running these monsters takes a city's worth of electricity. I mean, look at this. A single next-gen data center could need 1.2 gigawatts. That's literally the output of a nuclear power plant. And this last one, this might be the most shocking of all. It's the data wall. AI learns from stuff humans make, right? Well, according to some projections, by 2026, that's just around the corner, we will have run out. We'll have fed it pretty much the entire internet. So the billion-dollar question is, what does an AI learn from after that? Which brings us to the big final question. We are actively, right now, building machines that can do the one thing we always thought was ours and ours alone. Slow, deliberate, step-by-step reasoning. And if AI truly masters that, it really makes you wonder, doesn't it? What's left?